Hello viewers, welcome to another exciting video. In this video, we will be looking at the August 2017 Science Paper 2 question C1. Question C1 reads, the structure below is for a polymer. The structure below is for a polymer. Okay, so we have our polymer there. That is our polymer. So we have this as our polymer. Okay, now we turn our attention to A1. A1 reads name the polymer. A1 reads name the polymer. Now, generally, when we look at this type of polymer, since we have two types of polymers, we've got additional polymers and condensational polymers. Additional polymers and condensational polymers. Now, if you see a giant structure, okay, full of just carbon atoms throughout, it's the carbon atoms that are linked together, then automatically if we have no oxygen, no nitrogen, we only have one carbon linked to another carbon, linked to another carbon, linked to another carbon, and so on and so forth. Automatically we know that this is an additional polymer. It is an additional polymer. It is formed when small molecules add to each other. Okay, they bond together. It's like you are putting the same compound together to get a giant compound. So you are adding these small molecules. So this is an addition polymer. Now, all addition polymers, their names start with poly. Their names start with poly. So the first thing we're going to do is on the name here, we're going to write poly. Okay, that is just the first part. It's not the full name. Then we turn our attention back to the structure itself. So the structure is here. Okay, we now look for repetitions in the structure. What is repeating itself? Okay, that is what we're looking for. So if we turn our attention to the top, okay, to the top part here, all these are hydrogens. Now, because they are hydrogens, they will not help us see the repetitions. So we come and look at the bottom. So the bottom, the first thing we have is CH3 on this carbon right here. We have CH3. We go to the next carbon. Down there is a hydrogen. Okay? From there, we go to the next carbon. We have a CH3. So hydrogen, CH3. We go to the next, we have a hydrogen. So in this particular case, it's almost like after a CH3, there is a hydrogen. And after a hydrogen, there is a CH3. So this is repeating itself. So we can now draw a line. Okay, so here is our first. Okay, this is what is repeating. Okay, we come and draw another line. Again, here it's repeating. Okay, again, then we have that one. So in this particular case, we have 1, 2, 3 repeating units. These are repeating units. Now we want the name. Okay, we want the name. So for you to determine the name, you only need one repeating unit. Okay, you only need one repeating unit, and in that repeating unit, you need to count the number of carbons in the longest chain. So we are going to take the first repeating unit and we are going to see. So if this is our first carbon, then this will be our second carbon. This will be our third carbon. So there are 3. So the chain, the longest chain is like this. It's moving like this. If we check even on the next, it's almost the same there. Even here, it's there like that. All of them with 3 carbons. Now, in organic chemistry, Any compound with one carbon atom is the name will start with the meth. If it has two carbon atoms, it will be eth. If it has three carbon atoms, it will be prop. Okay, if it has four carbon atoms, it will be but. So in our particular case, we have three carbon atoms in the longest chain, so it is prop. So we are going to write that. Okay, we are going to write that it's a prop. So polyprop. Okay, polyprop. Now, the last part of the name here for addition polymers, the name will end with the prefix, with the suffix of ene. So it will be polyprop N. Polyprop N. This is the name of the polymer. Polypropene. Polypropene. So the name of the polymer is polypropene. Okay. We now turn our attention to A2. A2. So part A2, they're saying name and draw the structural formula of the monomer for the polymer. Name and draw the structural formula of the monomer for the polymer. All right, so this question has two parts. One requires us to write the name of the monomer. Now, what is the monomer? The monomer is, these are the small molecules that were used to make the giant structure. Now, if you already have a name for the polymer, just get the last part, remove the poly, and the last part will be the name of the polymer. So in this particular case, our name is poly. So if we remove poly, if we remove this part, what are we going to remain with? We are going to remain with propene. So our monomer, so this is coming from propene. So this is our monomer. So the monomer is propane. However, we need to draw the structural formula. Other than the name, we need to draw the structural formula. Now, how do we do that? So the structural formula of this polymer, since we know it's propane, okay? So we are going to have, propane has got three carbon atoms. So it's 1, okay, 2, okay. Then we have a double bond there, okay. Then another carbon, okay. So this will be the backbone, if I can say, the backbone of our alkene. The monomer is always an alkene. The monomer is always an alkene. So now we just need to fill in the hydrogen. So this one will have 3 hydrogens, which will be 1, 2, 3. Okay, the second one, okay, will only have 1 hydrogen. Okay, now if you count the number of bonds, okay, around each carbon, you need to have 4 lines. So we have 1, 2, 3, 4. Around each carbon there should be 4. So for this one we have 1, 2, 3, 4. So it's also satisfied. For the last one here, we are going to have 2 hydrogens like that. So this is the structural formula of the monomer. Now others will ask, but there is a CH3 there. There is a CH3. So this, okay, allow me to do this. So if we look at sorry, I'm just trying to highlight what is on the polymer itself. Otherwise, the answers are done. The answer, the structural formula of the monomer is this, and the name is that. However, I would just like to make a clarification. Okay, now if we look at the polymer, it has this CH3 there. Okay, it has this CH3 there, which is this one and this one. In our monomer, those are actually represented by this. That is the CH3 we see on the diagram there. Okay, so this is the CH3 we are seeing there. Okay, the other, yeah, okay, so that is that. All right, then we move on. Okay, we go to B1. They are saying state the type of polymer that is shown above. State the type of polymer. It is an additional polymer. It is an addition polymer. Addition polymer, or additional poly. It's addition polymer. Addition polymer. So it's an additional polymer. Additional polymer. Okay, then B2 reads, give one use of the polymer. Now, all these polymers that we're looking at are generally just plastics. Okay, and what are the uses of plastics? Okay, and sometimes the examiner may even ask the environmental effect. They may even ask on whether what does the word biodegradable, non-biodegradable, or such terms. So here they just want one use. So you can give the use of a plastic. Okay, so what are plastics used for? There are so many. So I'll just stick to the basic. So it is used to manufacture plastic bags. So it is used to make plastic bags. So it is used to make plastic bags. That's all. It is used to make plastic bags. All right. We now turn our attention to C. I think for the first time, I understand that I am supposed to actually give a full insight, and I'm supposed to write the answers fully. Okay, but for the first time, bear with me. I will not write everything for question C. Okay, for question C1C, but I will give what is needed in your answer. Okay, everything that is needed, I will highlight them. Okay, it is purely due to an availability of space. Okay, because these questions are usually answered on a separate answer sheet or in a separate answer booklet. All right, so question C, C1C states that ethanol is an alcoholic beverage which can be brewed from cassava. Ethanol is an alcoholic beverage which can be brewed from cassava. Outline the process by which ethanol can be prepared. Outline the process by which ethanol can be prepared. Now, in this particular question, we are limited. We are limited in the process we are going to outline. And the reason why we are limited is that they have mentioned the word. They have mentioned the word cassava. Okay, from cassava. Cassava, what is cassava? Okay, cassava contains carbohydrates. And what are carbohydrates? Carbohydrates are sugars. So we need to describe a process that involves the making ethanol from sugars. Okay, we need to outline process that will make ethanol from a sugar. Now, there are two ways in which we can manufacture ethanol. One, okay, it's hydrating ethane. Okay, when we hydrate ethane, we will make ethanol, but that does not involve sugar, so we will not look at that one. The other one is fermentation, okay, which actually is the breaking down of sugars to ethanol and carbon dioxide. Okay, the breaking down of sugars, okay, or generally the breaking down of glucose, which is uh, the basic unit of carbohydrates. The breaking down of glucose, okay, the breaking down of glucose to 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 alcohol using an enzyme. So in your statement, okay, so in our answer, what we need to show, the examiner that in cassava we have glucose, okay, or cassava can be broken down by enzymes to form glucose, and glucose is then broken down by the enzyme yeast, okay, to form alcohol. So now, what is there is this. First and foremost, we need glucose. We need glucose, and the first and foremost, we need glucose. So we are going to state that, okay, glucose will be broken down. So glucose will be broken down. Glucose will be broken down by the enzyme yeast, okay, to form ethanol and carbon dioxide. Okay, generally this reaction will actually be fast at a temperature. So at a temperature of about 37 degrees Celsius. So it all takes place at that. Then, okay, so the process is that glucose is broken down, okay? Glucose is broken down by the enzyme yeast, okay, to form what? Ethanol and carbon dioxide at a temperature of what? 37 degrees Celsius. And to do that, to validate, remember, it's 3 marks. So what you've just said, you've looked at the reactant, okay, the enzyme, okay, and the products, okay, and the products. You also now need to cement everything by writing a chemical equation for the reaction, okay? And how will this chemical equation look like? Okay, how will this chemical equation look like? Allow me to write it just between there. So the chemical equation for the reaction is going to be C6H12O6, okay, being broken down to what? C2H5OH, okay, plus, okay, CO2. So this is the equation. So if you put all those in your explanation, you will definitely get the 3 marks. Okay, all right, so that is about question C1C. Then we go to C1D. C1D. Ethanol is used as a fuel. Ethanol is used as a fuel. Construct a balanced chemical equation for its complete combustion. For its complete combustion. Now, complete combustion means that there is adequate supply of oxygen. And when there is adequate supply of oxygen, we only expect 2 compounds to be produced. Okay, and that is carbon dioxide and what? Water. Now, if it is incomplete combustion, it means that there is insufficient oxygen, and the products that will be formed will be carbon monoxide, okay, and there will also be soot, and there will be water. Okay, so these are 2 different things. So we need to construct an equation, a balanced chemical equation. So ethanol has got 2 carbon atoms, so it's in C2H5OH plus O2, giving us CO2 plus H2O. So this is the equation for the complete combustion of ethanol. However, we need to balance it. Now, one thing I advise people to do when it comes to balancing is that always balance hydrogen and oxygen last. Look at these last. And between hydrogen and oxygen, always balance the one that actually is alone last. Like this oxygen here. This contains only oxygen, no other element. So it is easier to manipulate this than all these others. So if it is balancing hydrogen and oxygen last, what we are going to do is we are going to start with the only other element, which is carbon. So on the reactant side, we have 2 carbon atoms. On the product side, we only have 1 carbon. So we are going to add a 2 in front there so that we have 2 carbon atoms here and 2 carbon atoms there. Okay, then we now turn our attention to hydrogen, because hydrogen is hidden so much in compounds. So what we're going to do is we're going to check on the reactant side, how many hydrogens do we have? We have 5 here plus 1 there. So we have 6 hydrogens on the reactant side. And on the product side, we only have 2. So what do we do to 2 to turn it into a 6? We multiply it by 3. So multiplying means we put a 3 in front there. So we have 3. We have 3, okay? We have 3 times 2, which is 6. We have 3 times 2, which is 6, okay? Which balances with the hydrogens there. So now we turn our attention to oxygen. Oxygen is the last man standing, okay? Now, what we are going to do with oxygen is this. On the reactant side, we have 1 oxygen here and 2, so total there are 3. On the product side, we've got 3 oxygens, okay, plus 2 times 2, which is 4. So 3 plus 4 is 7. So this side we have 7, and this side we have 3. Now, in these compounds containing oxygen, this one only contains 1. So it means that we need to change these 2 oxygens to have 6, so that when we say 6 plus 1 gives us 7. So we are just going to add a 3 there, so that it's 3 times 2, 6. 6 plus 1, 7, which is the same as there. So with that being said and done, okay, this becomes our balanced chemical equation. Our balanced chemical equation. This brings us to the end of this video. Thanks for watching. And if you've not subscribed, don't forget to subscribe and turn on the notification button, so that each time we have a video, you are notified in due course. Thank you very much. See you next time.